Welcome back to India's largest e-learning platform, Gradeup, and we are here in the series of engineering services top 600 previous years questions. Today I am here with the strength of materials part, my dear. So today we will be having some of the previous years questions from engineering services. They are going to be some of the top questions. Yes, and these will be the question like in a way that you can have the repetition of these kind of questions also. So guys, we are about to start the session. Please quickly like and share it so that others can also be benefited. I am fine, Sajal. So I am really happy with the continuity you are having. Yes. From morning to the evening. Gaurav, good evening, dear. Yes. So guys, let us see the questions we are going to discuss today. Yes. A small announcement that from 15th February Vision 2022 batch, 4th batch have already been launched, and as I told you that these are the unique features of the course, and this is the contact on which you can ask if any query is there for your juniors, for those students who are thinking of preparing for 2022. For them this course is going to be okay, guys. And the third GNST special, it is going to be a scholarship test which will be giving a scholarship of around 1 crore rupees is on 28th February. These are the branches eligible. Going to be a very wonderful thing if anybody is going for that. Mahesh, good evening, dear. Yes, so these are the announcement I am telling you. Post gate guidance session for the students who have given gate 2021 is going on at 7 PM daily on Gradeup app. Yes, guys. With this, we are starting the session with the first question in front of you. And my dear, today I am having the session from majorly simple stresses and strain, principal stresses. Okay. And daily, tomorrow also we will be discussing some of the question. And guys, in 3 sessions, I feel we will be completing some very good questions from the engineering services previous years. I can tell you one thing, that the question you will be looking here are going to be in your paper of ESE 2021, because it has been seen that in engineering services repetition is there. Yes, Vikas, good evening. So in engineering services repetition of the questions is there. So the very first question is the stress level below which a material has a high probability of not failing under reversal of stress. So my dear, as I told you, the most important topic in this subject is stress strain diagram, where questions are coming every year. Babu all-rounder, okay, very good, you have answered it, and Babu have answered as endurance limit. Any other guys, if somebody want to give answer, I am waiting, then we will move on to the next question. So today the first 10-12 questions are related to stress strain diagram. They are more theoretical. Then we will move on to the numerical questions. Yes. So my dear, yes, the answer is correct. It is endurance limit, and endurance limit, whenever you are talking about, it is nothing but it is denoted by SE, and this is that value of stress, my dear, for which the material or a component will never fail and having a life of infinite life, and an infinite life refers to 10 power 6 cycles. So this is the life a component will be having if you are saying below endurance limit. Yes, guys, let us see the next question. My dear, next question is this one. Very good, Sajal. Next question is this one. In a tensile test near elastic limit zone, tensile stress increases at a faster rate. Tensile stress decreases at a faster rate. Tensile stress increases in linear proportion to the strain. Tensile stress decreases in linear proportion to the stress. So my dear, it will be to the strain, not stress, to the strain. So my dear, if you are going to make the stress strain diagram for mild steel, it is going to be like this. Okay, so you can have the idea from here. Yes, Vikas, very good. For the previous, it is correct. What will be the answer for this question, guys? What will be the answer for this question? Very good, guys, very good. Get motivated. Dear, gate has gone. Yes, is still there. And in ESE, every year some average student is going to top there. Yes, Manfred Wedge is saying answer as C. Okay, Vikas Yadav is saying answer is A. Sajal is saying C. Vikas Yadav saying C. Gaurav Vajpayee B. Arun B. Babu C. So dear, first of all, I would like to say that if you see near the elastic limit zone, you can see here that near the elastic limit zone, first of all, this is the proportional limit. Up to this, the relation is linear. So obviously, my dear, linear proportion is there up to proportional limit. After that, it is not linear, it is non-linear curve. So as it is non-linear curve, my dear, C is not correct. And my dear, tensile stress decreases at a faster rate or increases at a faster rate. If you see, this is also wrong. So if you say near the elastic limit zone, you know this is elastic limit and this is upper yield point and this is lower yield point. So near to elastic limit is this zone. This zone is near to elastic limit zone. Here, my dear, you can see this is going to be a decrease in the stress, and that's why the answer is going to be B for this. Okay. Why the answer is not C? Because elastic limit zone does not give you the proportional limit. Up to proportional it is linear. After that it is not linear. Not linear. It is non-linear. So answer for this question is going to be, my dear, B but not C. That is a twist for this kind of question. Okay. Very good. Arun, Gaurav have given the correct answer. Vikas, fine. Let us see the next question, guys. This is the next question. Yes, Shiva. Yes, what is the answer for this? So guys, quickly share this session with your friends so that they can also come and take the advantage of this. So my dear, engineering services questions are slightly easier. Okay, but as I said, the time is also less, but nowadays numericals are also coming. So today I have taken majorly conceptual question. Tomorrow we will be having some of the numerical questions also. Okay. Today I have taken more conceptual questions. Yes. Gaurav Vajpayee is saying answer is D. Arun is saying answer is D. What about others? Vikas Yadav is saying D. Yes. Babu is saying answer is D. Sajal is saying answer is D. Fine. So dear, they are asking you about the toughness. You know, toughness is defined as the strain energy stored by the body up to fracture point. Up to fracture point, the strain energy stored by the body is said to be the toughness. So my dear, obviously toughness is going to be up to the fracture point. So this area will give you the strain energy per unit volume stored in the material before fracture. Yes. So this is said to be basically modulus of toughness. So answer will be D here. Okay, as he is mentioning in terms of stress strain diagram as shown in the figure. Very good, guys. D is correct. Next question is, okay, I feel here the question is not complete. This question is the next one. Again from stress strain diagram, guys. Yes, Vishal. Good evening, Pranam. How was your paper, Vishal? How was your GATE exam? Shiva, very good. Ullas, very good. Sajal, very good. So dear, it is a good practice if you are joining this session. This session is helpful for 2021, GATE 2021 audience, GATE 2022 audience. Even if you are going for engineering services, any exam, ISRO, DRDO, it is going to be helpful. WISAG. Yes, dear, very helpful series. Yes. Yes, guys, please share the session with your friends also. Quickly like, share, subscribe. Okay, okay, Vishal. Next year I feel you are going to appear. It's fine. Shailesh is saying answer is C. Okay. What about others? What about others, guys? What about others? Arun is saying A. Vikas is saying C. So different people, different answers are coming once again. Rahul is saying A. Okay, fine. So my dear, which of the following is not correctly matched? First of all, I am going from D. Isotropic material. So my dear, isotropic material, iso means same, tropic means all the direction. So my dear, if elastic properties are same in all the direction at a point, so obviously this is correct. Orthotropic material is something where elastic properties are not same in three mutually perpendicular direction. Yes, different properties in three perpendicular direction. That is also correct. My dear, strain hardening definitely increase the stiffness of the material. So this is also correct. Strain hardening of material is giving the stiffening effect at some stage. So my dear, if D, C, B is correct, the wrong one is viscoelastic material, small plastic zone. Viscoelastic is a material which is behaving like both viscous and elastic. Okay, so my dear, viscous plus elastic. So my dear, obviously small plastic zone is not the correct match for this. So A is going to be the answer here, because this is the pair which is not matching. Okay, this is the pair which is not matching. So Gaurav Vajpayee, Shiva, Babu, answer A is very much correct. Sajal, you made a mistake here. Let us move to the next question. So my dear, viscoelastic material is something having viscous plus elastic effect. Okay, viscous effect, you know, it is related to the shear, and this is, you know, elasticity. So my dear, that kind of thing you study in the fluid mechanics. Next question is this one. So my dear, why I am showing you these kind of questions, because these kind of questions every year are coming from engineering services, and these are the questions where students have more doubt. Nowadays generally students are more feeling more difficult in theory questions. And one more thing I would like to suggest you guys, those who really want to improve your marks, paper 1 plays a very important role. I don't know why you guys are not joining the paper 1 classes which are going on every day at 11 a.m. Tomorrow I will be there at 11 a.m. to teach you the crystal defect. And I would like to announce you here that from Wednesday onwards, we will be starting a crash course for paper 1 like we have done it in GATE paper. So like we have done it in GATE, in engineering services, we are coming with a crash course for ESE paper 1. So be ready with that. Every week one subject we will try to cover. We will be completing that crash course at the end of May, and every month you will be having 2 to 3 subjects we will be covering for paper 1, and it is going to be very useful for all of you guys. Okay, you all can join us. So we will be discussing about project management, engineering drawing, design, safety, all the topics will be covered. Yes. So for this question, my dear, there are list 1 ductility, brittleness, tenacity and toughness. List 2 failure without warning, drawn permanently over great changes of shape without rupture, absorption of energy at high stress without rupture, high tensile strength. So my dear, we need to see which of the following is going to be correct. So Shiva is saying answer is D, Tork is saying answer is D, Arun is saying D, Gaurav Vajpayee D, Rahul Bura D. So my dear, let us see which one is going to be the correct one. If you see, my dear, ductility, brittleness, tenacity and toughness. So I would like to say failure without warning is the brittleness. So B is going to be with 1. So by looking at this, even you can answer it. D is going to be the answer. But still I will be giving you, dear, that is the beauty of engineering services question. That only by looking at one thing I have answered it. So that is how you can save the time. So when you feel that some term is there which you have never think of, when you have never heard of, so I did just check by only one option you will be able to answer this kind of question. Okay, so my dear, first of all, when you solve this question, ductility is related to drawn permanently, great changes of shape without rupture is ductility. You know, tenacity means high tensile stress. So high tensile stress or ultimate tensile stress, both are said to be tenacity. And my dear, toughness is absorption of energy at high level of stresses without rupture. So option D is going to be correct one, guys. Wonderful, because all of you, very good. Let us move to the next question. Next question is this one. Yes, let us see how many of you give the correct answer for this. So guys, as one question is sure shot from stress strain diagram, that's why I am taking first 15 question from stress strain diagram only. And all these are previous year's ESE question which are going to repeat every year. So my dear, these will give you confidence also. By this series, I am confirming more than your 60 to 70% marks in technical, which generally are going to be repeated also. Yes, please solve it, guys. Please solve it, solve it, solve it. What will be the correct answer for this? Yes. Yes, answer it, guys. Vikas Yadav A, Babu A, Shubham Arora A, Sajal B, Arun D. Very good. Let us see. The maximum strain energy stored per unit volume in a body without permanent distortion is, obviously my dear, when you are saying this without permanent distortion, the maximum value is proof resilience. Basically the maximum value of, but dear, if you say this, the maximum strain energy stored per unit volume. So my dear, when you are saying strain energy per unit volume, proof resilience, if you say, is the maximum value of resilience. It is the maximum value of resilience. And if you say this is the maximum strain energy, not strain energy per unit volume, modulus of resilience is the maximum strain energy per unit volume. So my dear, if this is the case, I would like to say that the answer is going to be modulus of resilience. Okay, this is going to be the answer. Yes, many of you have done the mistake here. Yes, dear, that is the twist in this question. So, Chandra Kiran, Rahul Bura, Raj, Gaurav, Sajal, Shiva, Arun, Shubham, yes. That is how the examiner going to confuse you. He is asking about strain energy stored per unit volume. So, dear, modulus of resilience is per unit volume. Proof resilience is not per unit volume. That is the point. Okay. Yes, dear. Wonderful. Let us move further. Next question is this one. That is related to creep. Creep is a property, my dear. That is related to creep. Creep is a property. Let us see how many of you give correct answer here. About creep. Yes. About creep. Yes. Yes, guys. Very good. Very good, guys. This time the question is creep is the gradual increase of. My dear, what is creep? If you want to understand, let us say this is the rod of your fan, and on this the fan is hanging, and because of the hanging of fan, you know there will be some elastic deformation in this bar. And my dear, if the elastic deformation will be there in the bar, what happened is with the time elastic deformation gets converted into plastic. So my dear, with the time elastic deformation is going to be converted into the plastic deformation, and that is said to be the phenomena of creep. So my dear, it is going to be plastic strain with time. So creep is gradually increase of plastic strain with time at constant, elastic strain with time at constant load, plastic strain with time at varying load, elastic strain with time at varying load. So plastic strain with time at constant load. A is going to be the answer. Yes, very good. So my dear, creep is a property. Creep is a property, my dear. It is basically saying that if this is the elastic deformation, if you are holding this load for longer time, elastic deformation will be converting into plastic deformation. So my dear, this is the phenomena of creep. Majorly we will be studying this phenomena in the material science part. Yes, very good guys. Next question is this one. Now these theory questions are about to over and the numericals questions will be coming. So very good guys, just share the session with your friends. This is the series dedicated to engineering services previous year's question, because generally students are searching for this. Yes dear Arun, temperature plays a very important role in creep. If temperature is going to be more, the effect of creep will be more. It is for sure, definitely. Yes it is. Yes it is Arun, very much. Yes. So dear, solve this question. Tell me the answer about this. Yes dear. Raj is saying answer is A. What about others? Neha is saying answer is D. Okay. What about others? Ullas is saying D. Arun is saying C. Sajal is saying D. So my dear, isotropic, homogeneous, viscoelastic, brittle, time dependent stress strain relation, no plastic zone, identical properties in all direction, similar properties throughout the volume. So my dear, identical properties in all direction is related to isotropic. So A with 3. It means answer will either be A or will be C. Then my dear, similar property throughout the volume is homogeneous. So B with 4. So B with 4. C is going to be the answer. Yes. So my dear, now viscoelastic means time dependent stress strain relation. So now you got the meaning of viscoelastic, as this term also previously came, and brittle means no plastic zone for sure. So answer for this question will be C, my dear. Very good Babu, very good. Neha, very good. Yes, wonderful guys, wonderful. मजा आ गया. चलिए आगे बढ़ते हैं. So my dear, next question is this one. A ductile structure is defined as one for which the plastic deformation before fracture is. These are the options. Let us see how many of you give the correct answer for this. Let us see how many of you give the correct answer for this. So my dear, those students who want to really score good in engineering services, paper 1 preparation is a must. And my dear, right now material science is going on and you can definitely prepare with the classes going on the YouTube, because I am taking the things in a wonderful complete manner. Likewise, it is asked in the examination. So be ready guys. Tomorrow I will be discussing about the crystal defects part. So it will be great if you are joining me tomorrow. Okay, it will be great if you are joining me tomorrow at 11 AM. And also share this with your friends. It is a free series. And it will be going on for next 2 months, not 2 months, next 3 months, March, April and May. In 3 months, every month we will be covering 3 subjects. Okay, so 10 subjects are there. July, your examination is there. June first week we will be completing this series. and dear, I can guarantee you that no other platform will give you that kind of series what we are going to launch with, because paper 1 is not taught everywhere in a good manner. So that keep in mind. Yes, very good guys. Many of you have given the correct answer. Ductile means plastic deformation. So if plastic deformation is much larger than the elastic deformation, then it is said to be ductile structure. So D is going to be correct one. Like if you see mild steel, my dear. So for mild steel, stress strain diagram is going to be like this. Elastic deformation is very less and plastic deformation is quite bigger. That is something the case. Next question guys. This is M square. Next question. Now the numerical part is coming slowly. Yes. Yes, Arun, you are very much correct. In Gradeup Super, in the paid courses for technical, we have already planned a complete preparation package as a crash course, and that is going to be started in the March month. Okay, and that will be covering all the subjects for you guys. Yes, Sajal, don't worry, you can correct your mistake now. This is the right time, this is the right series, and you are at the right platform. So don't worry, you will be able to solve your queries. Now what about this question? Now the numerical part is starting guys, but you know in ESE calculator is not allowed. So I want you to do it in a nice, wonderful, great manner. So just have a good practice of that. What is the answer for this? The question is, my dear, if all the dimension of a prismatic bar elongation under its own weight are increased in the proportion m is to 1, then the total elongation will increase in the ratio of. They are saying that if you are going to have a bar under its own weight, then you know, my dear, deformation total is coming out to be. It is coming out to be. Yes, what it comes? It comes rho g L square. Is it coming in this way? Rho g L square upon 2e. This is the elongation. And he is saying if all the dimension, like it is a circular bar, so there are two dimensions, length and diameter. So he is saying if length and diameter both becomes 2 times, how much time the deformation will be? But it is not going to be 2 times, it is going to be m times. So how much times the deformation will become? Yes. Some are saying D, some are saying B. So my dear, I would like to say the answer is B, because you know that if the dimensions will become m times, then my dear, this delta total is depending on L square, but there is no diameter or area term. So delta total is directly proportional to L square time. So if L will become m times, so my dear, delta total will become m square times. So answer is going to be B for this. Wonderful guys. Once again, Sajal, you have made mistake. Yes, next question. This is, as I said, calculation started now. Numerical started now. Yes, what is the answer for this question? This is again from Engineering Services technical paper. Very good guys, wonderful. सभी से होना चाहिए. Yes. Yes. Guna Shekhar, answer is A. Bhargav, answer is A. चलिए बहुत बढ़िया. Yes, my dear. So in this case, what we do basically, first of all, we will assume that, let us say this is point A, this is B and this is C. We will assume there is a support reaction RA. We will assume there is a support reaction RC. So my dear, you know that by equilibrium you will be writing Ra plus Rc is equals to P. This is one equation. You know it is fixed from both the ends. You can also write, if this is bar 1, this is bar 2. You can write delta 1 plus delta 2, which is delta total is going to be 0. So delta 1 is going to be minus delta 2. So my dear, P1 L1 upon A1 E1 is going to be minus P2 L2 upon A2 E2. So my dear, when you will be finding out P1 and P2, you will be using the method of section. So when you will be using the method of section, you will be taking section here. And you can write P1 is equals to plus Ra, because Ra is acting away from the surface, it is tensile. So P2, if you will write, if you take section here, Ra is away, P is towards the section. So it is going to be plus Ra minus P. So my dear, when you will be putting this value, you know that L1 is 2L by 3. L2 is L by 3. So P1 is going to be Ra. L1 is 2L by 3. And area is throughout same, and Young's modulus of this is copper. So I will say A into E copper. Then minus P2, my dear. Minus P2. P2 is Ra minus P. It is Ra minus P. Okay. And then it is equals to L2 is L by 3 divided by A, it is E of steel. A will get cancelled out, L by 3 will get cancelled out. E of copper, E of steel will give you 2 here. Okay, this is 2 here because E of S is 2 times E of copper. So my dear, you will be getting P to be, sorry, Ra to be P by 5. So R is P by 5. So you have to answer what is the you need to answer what is the force in copper. So in force, copper is Ra plus Ra is P by 5. So P by 5 tension is the correct answer. So answer is going to be A, dear, A, because this is coming out to be positive, and once this is coming out to be positive, my dear, it means the assumed direction is correct. So section ke away from the section is tensile. So answer is A, but not the C. Guna Shekhara, if you got it. Money, very good. Bhargav, very good. Very good guys. Those who have given the correct answer, wonderful. So guys, if you say, let us move further. Any doubt, please ask me. I will be clearing your doubt. This question I have solved previously also when we were practicing for GATE, because this is the case where shortcut is not applicable. Next question is this one, guys. Next question is this one. Yes, this type of question also I have solved previously in GATE practice sessions. But this question is from Engineering Services paper. It is a very good question, and hope everybody of you will be able to answer it correctly. Yes guys, just try to solve it. Very good guys, very good. Keep solving. Yes, Guna Shekhara, Sajal, Shubham, Arun, Gaurav Vajpayee. Okay, Babu is saying answer is C. Very good, guys. Yes. So my dear, for this kind of question, you know that as the force is acting, under this force, this rod is going to deviate like this. So here the deviation is going to be delta A. Here deviation is going to be delta B. This is the point, D is nothing but the point of hinge. So my dear, if you see here, I can show you the two similar triangles. This is one similar triangle, this is another similar triangle. So by looking at these two similar triangles, you can write delta A by 3A is equals to delta B by 2A. So AA will get cancelled out and you will be getting delta A by delta B as 3 by 2. You need to answer about the, yes, the stiffness of this is 2K, stiffness of this is K. You need to answer about the force in spring A and force in spring B. Krupal, it has been started from 11. Okay. क्यों नहीं पता लगा आपको? आप टेलीग्राम चैनल पे नहीं हो क्या डियर? टेलीग्राम चैनल पे वी हैव शेयर्ड अबाउट दिस सीरीज. सो यू कैन से फोर्स एट A and B is going to be stiffness of A into delta of A to the stiffness of B into delta of B. You know Ka by Kb. Ke आपको 2K दिया, ये K दिया, it is 2K by K and delta A by delta B is 3 by 2. The answer will be 3. So answer is going to be C. Yes dear. Sajal, very good. Shubham, very good. Gaurav Vajpayee, very good. Vikas Yadav, very good. Yes, Krupal. So you can join us regularly at 11 p.m. Fluid mechanics is already over. Now strength of material is going on. Again a wonderful question in front of you guys. It is related to rubber Poisson ratio. Yes, let us see how many of you give correct answer for this. Yes. Sabhi se hona chahiye. All must do the question. So guys, do you want a generic session for paper 1, that how to prepare paper 1? Do you guys really want that session? If you want, we can have that session also. Nearly same question solved in ISRO session. Dear, these in ISRO, whatever the question was there from previous year's ISRO, you can check from the sources. The question in ISRO we have solved was from previous year's ISRO. They are previous year's engineering services. So there is no match. If you see the question, they were different. Yes, you can have similar question 2 to 3. These were not the question. You can have a cross check there. My dear, ISRO DRDO question was previous year's ISRO. They are previous year's engineering services. How both questions can be same? 1 to 2 question maybe, not all. Ashok, don't ask this question because I don't have the answer for this. So after this session I will sleep and morning we will meet again. Yes. So Arun, it is not like that dear. These are the question. I am not making the question. I am just showing you the previous year's question. This is the question from previous years. You can check it. Okay. This is not the question I have made. Yes, I have done one thing. Like other people are sharing you the previous year's question of engineering services for mechanical. I am taking mechanical plus civil both. That is something I am doing different. ISRO questions were not ESE questions. Just check it. Yes. Rushikesh is saying D. Yes, my dear, D is correct answer because volumetric strain formula is 1 minus 2 mu upon E into sigma 1 plus sigma 2 plus sigma 3. So my dear, as you know, for rubber Poisson ratio is 0.5. 2 into 0.5 is 1. 1 minus 1 is 0. Volumetric strain will be 0. Yes, guys. Next question is this one. These are from the previous year's engineering services. Yes, dear. This is the question from previous year's engineering services. I don't know, Arun, why do you feel like this? You just check once the ISRO question. Similar they may be, they are not same. Similar I cannot change it now because they are previous years. If I would have taken my question, then you can say this thing. This is from previous years. Nobody can change previous year's question. Yes, my dear, a question from taper bar. Yes, those who have attended my classes, I solve some of these questions in class. Whoever paid course students are there I definitely solve these questions. So obviously in paid course I will be sharing, I will be solving from all the examinations some good question. So that's what I am here with you. Okay. Yes dear, what about this question? So it is a bar of circular cross section varies uniformly from 2D to D. So my dear, there is a taper bar whose diameter is changing from D to 2D. And L is the length. You know that if P is the force applied over it, then deformation of taper bar will be 4PL upon pi E D1 into D2. This is the formula for this. But they are saying if extension of the bar is calculating, treating it as a bar of average diameter. It was a taper bar, but somebody is taking it as a prismatic bar of diameter 1.5D. Average of these two diameter, then obviously according to him for this prismatic bar it is going to be 4PL upon pi E 1.5D ka square. He is asking about error in the measurement. Real my dear delta taper was this. Prismatic this is assumption, this is reality, this is theoretical. So you want to find out error percentage. You will be saying it to be delta taper reality minus prismatic divided by taper into 100. You will be getting the answer to be 11.11%, near to the 10%. In engineering services, KLCs are not allowed. So you will not get the correct answer. You will get the nearby answer for this. Okay. Everything is common. You can say 4PL by pi D square will get cancelled out. You will be getting some numerical terms. You will be getting 11.11%. Okay, so my very less number of students are getting the correct answer for this. Okay, very good guys, wonderful, बहुत बढ़िया, अच्छा जा रहे हो सभी. चलिए बढ़ते नेक्स्ट क्वेश्चन. ये हो चुका है ऑलरेडी. नेक्स्ट क्वेश्चन इज दिस वन. A cube with a side length of 1 centimeter. Now this is from thermal stresses. This is from thermal stresses guys. This question is from thermal stresses. Yes guys, from thermal stresses this question is. Fine Babu. Yes. Very good Shubham. So dear, you know that the question is a cube with side length of 1 centimeter is heated uniformly by 1 degree Celsius above the room temperature and all the sides are free to expand. What will be the increase in volume of the cube? So my dear, in this case volume of the cube is going to be, obviously it is alpha xx plus yy plus zz. Y epsilon xx yy zz, because for rectangular body this is the case. And you know this is alpha delta t plus alpha delta t plus alpha delta t. The answer is 3 times alpha delta t. The answer is 3 alpha because delta t is 1 centimeter cube. A is the answer. A is the answer. Okay dear, because they have asked about the increase of the volume and it is the case of free expansion. So in free expansion, this is the change of volume. Okay, very good Ashok, Ullas, Shubham. I feel Vikas, you have misunderstood the question. That's why the answer given is wrong. So dear, as this is the first session of SOM, slowly the level will increase. Okay. So this question, what do you feel? What will be the answer, guys? This is the question which you have seen many times. Again in unique services question previous years. Okay, Sajal, which question, about this or the previous one? Yes. Yes, guys, solve it. So engineering services question, ISRO question, level is same, questions are not same. Okay. Yes, guys. Arun, very good. So your answer is correct. Very good, Arun. So a cube having each side of length A is constrained in all the direction. So there is a cube, my dear, and this cube is constrained in all the direction. Sigma, sigma and sigma. And my dear, it is uniformly heated. It is uniformly heated to T degrees Celsius. Alpha is thermal expansion and the cube material is E and stress develop in the cube. So my dear, you know one thing, that if you are going to write the XX, YY and ZZ, XX, YY and ZZ. So as you know, my dear, the tendency of change of volume, if it is free expansion case, it will be 3 alpha delta T. You know, this will be the tendency. But at the same time, you know, because of the stress component, you will be having 1 minus 2 mu upon E into sigma 1 plus sigma 2 plus sigma 3. And you know that this is the volumetric strain by the formula, this is by the thermal. So my dear, volumetric strain because of thermal plus volumetric strain because of sigma is going to be 0. Okay, this is because of temperature, this is because of forces. Net is 0 because it is already written that this is constrained. So my dear, obviously when you will be taking this, one is going to be plus, other is going to be minus. Why? Because sigma 1, sigma 2, sigma 3 all are compressive in nature. Okay, if you are not putting plus minus, you will be taking the real value, then also the answer will come. You will be taking it to be plus 3 alpha delta T. And this is going to be 1 minus 2 mu upon E. And every sigma 1, sigma 2, sigma 3 is the minus sigma. So it is minus 3 sigma is equals to 0. And by solving, sigma will be coming out to be alpha TE upon 1 minus 2 mu. This will be the answer, guys. Wonderful. You guys have done it in a good manner. Next question is this one. And my dear, this is a very good question. Even I would like to say that for this question, many of the previous years textbooks, publications, whatever they are saying, they are giving the wrong answer. Yes, those who are my paid course, those are from paid course students, those already have seen these questions in the classes, some of them, because I always take good questions from all the exam in the courses. So obviously, if you have attended my course, some of these questions you have seen in the class. But they are previous years engineering services question. And this is from 2016. Recent questions it is. From 2016 it is. Yes guys, please share the session, like the session, subscribe the channel so that others can also reach to this session. So we are giving some effort for you guys. We are just making the questions, searching good questions for you in this series so that you can check your level of practice. Even generic session, when we are making it, we are getting the information from various sources, from many students who have done the thing, so that we can give you the authenticated information, not like anything we are saying, coming on to YouTube saying anything, not like that. So every time a lot of efforts are there for you guys. So just take the benefits of these efforts. Yes. So guys, I want you all to come in the morning session for material science. You will be learning something new, and then after that we will continue with the crash course about other paper 1 subjects. So in the arrangement as shown in the figure, the stepped steel bar ABC is loaded by a load P. This is the load P, my dear, acting, and the material has a Young's modulus of 200 GPa, and the two portion AB BC have the area of cross section 1 and 2 centimeter square. The magnitude of load P required to fill the gap up to 0.75 mm is. So my dear, you know that this is bar number 1, bar number 2. If you say delta total is 0.75 mm, so delta total can be written as delta 1 plus delta 2 is 0.75 mm. My dear, delta 1 can be written as P1 L1 upon A1 E1 plus delta 2 is P2 L2 upon A2 E2, and it is going to be 0.75 mm. So my dear, you know already that when you are going to say L1 L2 are equal, A1 A2 are obviously different, it is given to you, material is going to be same. So E1 E2 are same. Okay, I cannot cancel here obviously. So my dear, if you are going to solve it, I am showing you how to solve it. You will be finding out P1 and P2. Apply the method of section here. You know, because of this P, some reaction will be coming here P. So you will be finding out P11. It will be coming out to be plus P. P22 will be coming out to be 0. So this will become 0. And by solving P2, you will be getting as, yes, the answer will be 15 kilonewton. Yes, guys. But they have given the answer 10 kilonewton. That is the mistake in those books which are coming from various publications. Very good, guys. Let us see the next question. Consider the following statements. Sajal, note 25, it is 15. The question is, consider the following statement, my dear. Modulus of rigidity, bulk modulus of a material R. So modulus of rigidity is 60 GPa and Young's modulus is 140 GPa. Then, sorry, not Young's modulus but bulk modulus. This is bulk modulus. G and K are given to you. Then they are asking E is this one or E is this one. Mu is this one or mu is this one. Yes. This is a numerical type question now. It is a numerical. Just try to solve it, guys. Very good, guys. Really wonderful. Solve it. This is a numerical. You need to use the relation of elastic constant. E is equals to 2g 1 plus mu. E is equals to 3k 1 minus 2 mu. E is equals to 9 kg 3k plus g. Use this one. You will get E. After getting E, use this one or this one. You will get mu. Very easy. Very, very easy. Yes. Gaurav Vajpayee is saying answer to be D. Means Poisson ratio is 0.3 and elasticity is 158. Uma Devi is saying B. Means 2 and 4. 2 and 4 cannot be correct. 2 and 4 cannot be correct. Both cannot be Poisson ratio values. Uma Devi. Yes. So very good guys. What about others? Very good Ashok. So answer will be D for this. 2 and 3. So when you will be solving, you will be getting E to be 158 GPa. And when you will be putting E is equals to 2G1 plus mu, mu will be coming out to be, my dear, 0.3. Wonderful. Harsh, I would like to give you my email ID. You just take this Dheeraj dot Sardana @ Gradeup.com. You just mail me on this email ID. I will share my contact with you, then we can talk. Okay? If you want to ask any question like this. Okay? And also there are many videos in which you find my channel also on YouTube. There you can see my contact if you want. You can also contact me on social media via Facebook. Yes. This is the next question. Which of the following is true? Yes, guys. Yes. Shubham is saying A. Ravi Teja is saying B. Uma Devi is saying A. Yes. So my dear, definitely Poisson ratio lies between 0 to 0.5. A is going to be the correct answer. For engineering material, this is true. Okay, I feel here figure is not there. Yes. If value of Poisson ratio is 0, what does that mean? Yes, please like, share, subscribe. The value of Poisson ratio is 0, then it means the material is going to be. Yes, guys, a very good question. Very, very good question. Ashok, for rubber Poisson ratio is 0.5, not 0. Yes. Okay, some are saying C, some are saying A. So my dear, you must know Poisson ratio is defined as lateral by longitudinal minus, and you must know one thing, that when you are going to define Poisson ratio and when you are saying Poisson ratio is going to be 0, you know that E is equals to 2G1 plus mu. E is equals to 3K1 minus 2 mu. And the options are, there is no longitudinal strain. The material is perfectly plastic. The longitudinal strain in the material is infinite. So obviously, my dear, if you say mu is 0, I feel D should be the correct answer, because rigid means no sir, that was for previous question, maximum. Okay, fine Ashok, very good. Arun, very good. So my dear, answer is going to be D for this. If you are going to say rigid body, my dear, for rigid bodies, deformations is 0, then you will be getting 0 by 0 format for this. Okay, so this is going to be the D. Yes, very good guys, wonderful. So next question, this is D is the answer for this. Next question is this one. A tapering bar with D1 and D2 diameter. There is a taper bar, diameter D1 and D2, and a bar of uniform cross section D. A bar of uniform cross section D have the same length and are subjected to same axial pull. They are subjected to same load. And after applying the same axial load, both the bars will have same extension if D is. So if delta of taper is equals to delta of prismatic, what is the value of D in terms of D1, D2? Yes, my dear. Gaurav, Vajpayee, Ravi, Teja. What about others? I want everybody to answer this, guys. Just 15 minutes more I will take for you guys, not more than that. Only 15 more minutes. So guys, are you happy with this series? Yes. If you want, we can increase the number of questions for you so that you can have more benefits from that. More practice, more benefits. Very good, Uma Devi. Answer you are saying is B. So you know delta taper will be coming out to be 4PL upon pi E D1 D2, and delta prismatic will be 4PL upon pi E D square. When you will be equating them, D square will be coming out to be D1 D2. So D is going to be square root of D1 D2. So my dear, the answer will be D is equals to D1 D2. Very good. Wonderful guys. बहुत बढ़िया. A cylinder bar of 100 mm square cross section is subjected to loading. Okay, figure is not there. I feel figure is missed. Let us see this question. The Poisson ratio of a material which has Young's modulus of 120 GPa and shear modulus 50 GPa. All these are the engineering services question, my dear. So engineering services ask the question of this level. These are the types of question coming in engineering services paper. Yes, very good, Gaurav. Fine, we will do that. Yes. Okay, 5-7 more minutes, guys, for today. Don't worry. Not more than that I will take. But tomorrow we will increase the session length to 1.5 hours because tomorrow I will be having a lot of questions. Today, as the first session was there, I have not taken much. I have taken only from the important topics, simple StressStrain or stress strain diagram. And when I will be coming tomorrow I will be taking question from principal stresses, SFDs, BMDs, bending torsion. Okay, and I will be taking one more session, means 3 sessions will be there for strength of material. Yes. Vikas Yadav, Ullas, Uma Devi, Arun. Very good. So you know E is equals to 2G1 plus mu. E is 120, 2 into 50, 1 plus mu. So it is, you can see without Kelsey you can find out. So that's why Kelsey is not allowed in this paper. So the level of paper is slightly easier than you expect in GATE. A straight bar is fixed at edge A and B. Okay, I feel figure is missed for 2 to 3 question. Okay, I am making this question for you. Don't see the option, answer it independently. If this is a fixed bar we are having edges A and B. E is the Young's modulus of elasticity, and load P is acting for 120 Newton. This is 120 Newton is acting here, and this distance is 1 meter. This is 2 meter, and you need to answer about the reactions at end. You need to find out the reactions at end. Options are not there. Don't see the options. This is the question. Only the length value I do not remember. Rest is same. This is the figure. So sometimes this typing error is there. Sajal, there are many who have already given GATE and they're looking forward for engineering services. They're looking forward for ISRO, DRDO, BARC. Okay, because GATE is definitely a way, but GATE is not only the way. Okay, solve it, guys. Solve it. Yes, you just need to apply the method of section. Okay, even area and E are same. You can go for shortcut also. If you want, you can go for shortcut also. I will assume that this is going to be the support reaction RA and this is the support reaction RB. Now you can go for the shortcut, guys. No issue, Bhanu Rajan. Actually, as you are getting 80 marks in the mechanical paper, it is a very good thing in set 2 getting this marks. I will say congratulations to you. And Bhanu Rajan, I want to know that in which batch you were. I want to know the batch of yours. Because I feel many times we interacted and really it is a very good score. I will definitely say congratulations to you, and I want to know the batch you were from. Yes, so that other students can also know about you. Those are your juniors who are going to give exams. Yes, don't worry dear, when you are getting that much score in mechanical, what is the need of XE now? XE was an option if mechanical is not going good. Very good, Gaurav Vajpayee. So if you are going to use the shortcut, you will be writing RA is equals to plus load value, distance from opposite end to the total one. It is coming out to be 80 Newton. And RB will be coming out to be 40 Newton. So if you see, D option will be correct one. Yes. As I said that I do not remember the figure correctly, but this was the figure only. Okay, the distance I was not sure, now I am sure. Yes, D is the answer for this. Very good, guys, wonderful. I joined late on rank up. Okay, I watched the recorded lecture, sir. Gear up and rank up, but I watched your live free lectures also. Okay, fine. Thanks, Bhanu Rajan, for that. And I wish you best of luck also. And you really rocked the exam. You have done in a wonderful manner, and really congratulations to you. You are going to get some PSU for sure. Okay, so Sajal, that student is inspiration for you guys, because he is our ex-student of last year and you are the present student. So definitely he is inspiration for all of you. Just have the guidelines of such students, how they prepared. You will be getting benefit of that. Sir, in ISRO last year paper from TOM vibration questions only asked. So can I take light for other concepts in TOM? Dear, from where you want to say? Definitely you need to go for, no, you don't take it lightly. You don't take it lightly, my dear, because you don't know that next time they may be asking much question from TOM, no question from vibration. Things keep on changing. So don't get dependent on these kind of things. विकास रावत, if you want to think about sir GATE के लिए self study कॉलेज के साथ कैसे करूं? Dear college going students को मैं हमेशा एक advice करता हूं that whenever you are getting holidays, public holidays, then concentrate more over GATE and ESE, and whenever you get university exam mid-semester, then concentrate over colleges. You need to make a wonderful balance, then only you can do something in this. Yes. Thanks Bhanu Rajan, and don't worry, as whatever the marks you are getting, you will soon be getting the offers of this type. As you are going to get very good rank, you will definitely be, if you want to teach, the doors are open for you always. Gaurav Vajpayee saying answer is D. A solid uniform metal bar of diameter D length L is hanging vertically from its upper end. The elongation of the bar due to self weight. Yes, you have seen delta is coming out to be rho g L square upon 2E. So delta is directly proportional to L square. It is not at all a function of diameter or area. So my dear, answer is going to be D for this. No doubt about that. Yes. Yes, guys. Don't worry, Sajal. After gate results, we will have a session with Bhanu Rajan. Okay. So after results, we will have a session with Bhanu if you want. Okay, as Bhanu is our student, so he will be available, I feel. He will share his experience with you guys. Don't worry. Fine. Arun A, Uma Devi D. So an orthotropic material under plane stress condition. My dear, when we are talking about orthotropic, total elastic constants are 12, independent are 9. D is the correct. If the material is anisotropic, total are 36, independent are 21. If the material is homogeneous and isotropic, total are 4, independent are 2. Okay. So I feel, guys, these were the questions for today, and now I would like to say that so I was feeling very nervous before. Yes, I know you talked me about that. Okay, thanks dear. So I remember we had a discussion about that. You were feeling nervous, but as I said that everybody feels nervous during examination. So it is nothing new in that if you feel that. So, but obviously you have done it in a wonderful, nice manner. You managed it very well, and I feel you will be doing something good in the future. And definitely looking forward to meet you in some of the sessions. So definitely, guys, I would say goodbye here to all of you. And tomorrow, my dear, we will be having discussion over more number of questions. Tomorrow session will be for 1.5 hours. Level of questions will be slightly better. And they will be previous year's questions only from from engineering services. And today the topic was simple stresses strain. Tomorrow we will be having question from principal stresses, SFDs, BMDs and deflection. And next day we will be having from other topics. So in 3 days we are covering, I feel, more than 150 questions, so that we can do better practice, good practice, number of questions, so that we can perform better in examination. So goodbye, guys, to all of you. Good night for today, and we'll meet tomorrow on the same time. You can join me at 11 AM for material science crystal defect topic for tomorrow. Okay, Jaswant, basically for JRF we will be having separate session, because for different examination we give different guidelines. So this is basically for engineering services. For JRF, definitely you need to go for, first of all, there are many NITs and ITs which gives the vacancy for that. Some of them will be taking from GATE, some of them from NET, some of them will be having their own examination. So definitely still technical is going to be same. My dear, whether you are going for GATE, you are going for engineering services, you are going for anything, all these examination, my dear, technical remains the same. Sure, Vikas Yadav, I will be sharing the PDFs right now, and also I am sharing the PDFs of other topics also. Dear Arun, I feel you had a misconception about this. So I would like to remove this. As we have said, when we are going to have PL upon 2AE, basically when a bar is under self weight, in the class I explained already that if it is under self weight, you know that you are finding out delta was coming out to be WL upon 2AE. Yes, it is correct. But here W is not the applied load. Here W is the weight of the bar. So my dear, if it is the weight of the bar, it can be written as mass into G. Mass can be written as rho into volume into G. It can be written as rho into area into length into G. So when you will be putting these values, it will be coming out to be rho A L G into L divided by 2AE. So here area will get cancelled out and you will be getting rho G L square upon 2E. So my dear, that is the confusion with many of the students. Arun, I feel now you are very much clear about the concept. So you were having some misconception related to that. So guys, please like, share and subscribe before leaving the session. And goodbye for today. Good night to all of you. We are meeting tomorrow morning 11 AM for Material Science Engineering Services paper 1. It will also be helpful in technical paper. Dear Abhinav Sharma, PDF you will be getting in the Telegram channel, and the link of Telegram channel you can see at the top chat. At the top chat level where pin is made, Gradeup Gate ESE PSU exam preparation is the Telegram channel. You can just go into that. Okay, fine Arun, don't worry. Goodbye guys for this session. Thanks for joining again. We are meeting tomorrow morning for Material Science.